In this lesson, we'll be talking about linear equations in two variables. Specifically, we'll be talking about slope, slope-intercept form, and some related ideas. So first off, the slope between 2 points on a line is defined to be like the rise over the run. So if we look at a line in the plane, and we look at how steep it is, we can measure the ratio of how high it rises over how far it goes in the same period. So the formula that we use for this rise over run idea is this formula for m for slope. y2 minus y1 over x2 minus x1 is the standard formula for the slope of a line. When we want to calculate this formula, we can label one point x1 y1 and one point x2 y2. Now it doesn't matter which way we do this, but it is important to make sure that if you're going to do x1 y1 and x2 y2 that you always do y2 minus y1 with x2 minus x1. Always the first point should be coming from the same location when you do this. Always choose things in the same order. Let's do an example. So let's calculate the slope of the line that passes through these points. So I'm going to label these x1 y1 and x2 y2. So according to the formula, which is y2 minus y1 over x2 minus x1, we get negative 1 minus 1 over 4 minus negative 2. So that's negative 2 over positive 6, which is negative 1/3. And for the next one, let's do it again. 2 minus negative 2 over 2 minus 2. Well, that's 4 over 0. In this case, I've got something divided by 0, and you can't do that. So this is actually what we're going to call an undefined slope. You can never have a denominator of 0, and we'll talk momentarily about what that means. Now, in the previous lesson, we saw that horizontal lines have the form y equals some number, and the vertical lines have the form x equals some number. The slope of the horizontal line is 0, and the slope of the vertical line is undefined. Think about it. A horizontal line is just flat, no slope at all. But a vertical line, you can't really define a slope. It's almost infinitely sloping. We don't define a slope for vertical lines, we just say it's undefined. The slope-intercept form. Now this form is very, very helpful because the slope-intercept form gives you the power to calculate the slope of the line and get a full equation from it in a way that you can graph it very easily, maybe even faster than in the standard form. So slope-intercept form is y equals mx plus b. So this is the standard formula. We had standard form, which was ax plus by equals c. Now we've got y equals mx plus b. M is the slope, as we had before, and 0b is the y-intercept. This definition immediately gives me the y-intercept, immediately gives me the slope, and it makes it pretty easy to draw this thing. Let's do this. We want to write this equation in slope-intercept form. So standard form it's already in. But if I want to write it in slope-intercept form, I need to solve for y. So I'm going to subtract 3x from both sides. And these two are not like terms, so they're not going to combine. But I get negative 4y equals negative 3x plus 6. Now to get y by itself, I'll divide by negative 4, both things. I get y equals positive 3/4 x minus 6 over 4. And if you'd like, you can reduce that to 3/4 x minus 3/2. So what this says, according to the slope-intercept formula, is negative 3/2 is my b, my y-intercept, so I can draw that, and 3/4 is my slope. Now remember, slope is rise over run. So if I want to draw the line, I'm going to rise 3 and run 4. So rise 3 is 1, 2, 3. There's my rise 3. And then run 1, 2, 3, 4 to draw this point. So 3 and 4 was my rise over run. And now I just draw the line. So there's the line that passes through those 2 points, and we got it by slope-intercept form this time. Find the equation of a line with slope -2 that passes through the point 0, 3, then graph the line. Alright, so we've got y equals mx plus b. Remember that the slope being -2 is your m, so I can just plug that right in. M is -2, and now it passes through the point 0, 3, which is actually giving me the y-intercept. Remember, b is the y value for the y-intercept, so b here is 3. And that's the final line. So this is the equation of the line already. Quick and easy. From that, let's draw the points. First off, my y-intercept is 3. And then my slope is -2. So think of it like this. M equals -2 over 1. So we're going to fall 2, or go down 2, and run 1. And by the way, this is a very common question that sometimes comes up. Run is always to the right. Now if you run to the left, you have to reverse everything. So to keep everything consistent, the easiest thing to do is always run to the right. Anyway, a -2 means I'm going to go down 2, fall -2, and then run 1 to get our next point. So if I draw the line, that's -2x plus 3. I went down 2 and over 1 to do my slope. Next form that we can talk about is the point slope form. Now the point slope form is not anything particularly different. It's a rewriting of the slope formula, but the nice thing about the point slope form is that it gives us the power to write the equation of a line quickly from different types of information. So let me just point out, to do the point slope form, I need a point, x1, y1, which I will plug into the formula, and I need a slope, m, which I'll plug into the formula, and then the variables x and y I'm going to leave alone. They're part of the equation that results. Let's find the equation of this line. Passes to the point 3, 4, and has slope 3/2. According to this formula, I've got x1, y1 here. Y minus y1 is going to be y minus 4 equals m, which is my slope of 1/2, times x minus 3. And there you go. So I get y minus 4. Distributing the 1/2, I get 1/2 x minus 3/2. And then adding 4 to both sides, note that -3/2 plus 4 is actually 5/2. And then I can graph the line. So the y-intercept is 5/2, which is about 2.5. And then my slope is 1/2, so I'm going to rise 1 and run 2 to get to my next point. And then I just draw the line. You'll notice it does appear, even though I didn't draw it perfectly, to pass through the point 3, 4 that was given in the original problem. If we're given 2 points, we can quickly find the equation of the line between them by calculating their slope and then using one of these points in the point slope form. So let's do it. M equals, if I've got x1, y1, and x2, y2, y2 minus y1 over x2 minus x1. The same formula applies. I get -12 over 4, which is -3. The slope is -3, and I can use either point I want, and I will get the same answer. I choose the one that I labeled x1, y1. The formula is y minus y1 is 2 equals m times x minus x1. Make sure you choose both the y and the x from the same point when using this formula. I get y minus 2 equals -3x plus 9, distributing the -3. Adding 2 to both sides, I get y equals -3x plus 11. Next example. We've got 5, 4 and -2, 4. So if I want to calculate the slope, I've got 4 minus 4 over -2 minus 5, which is 0 over -7, and that's just 0. Really what you should know at this point is this is a horizontal line. As soon as you see that the slope is 0, you really don't have to do any work. All you have to say is y equals, and what y coordinate should I use? Well, the one that showed up in both points. So the final answer is y equals 4 when the slope is 0. However, for this particular one, I'll show you that we can still use the other form. If I do y minus 4 equals the slope 0 times x minus 5, we get y minus 4 equals 0, and hence y equals 4. So it does work that way. However, in the case of the vertical line, we don't have a choice but to use this idea of I know what the line is because I see its particular slope. The next one is for you guys to try. Feel free to try this and then come back to the video. Just to go over your work, we get -1 minus -1 over -5 minus -2. I get 0 again over, looks like -3. That's 0. So, since it's horizontal, I get y equals, the common point for the y coordinates is -1. Next one is 3 minus -1 over 5 minus 5. I get 4 over 0, which is undefined. Since I'm getting an undefined slope, I know that means a vertical line. For a vertical line, the equation is x equals, the common x coordinate here is 5. So that's the only way to tackle this particular problem. Make sure that whatever x value is repeated, that's the one that we use for our point.